In this video, let's talk about another quintessential application of Calculus 2 techniques to physics problems, and that's to calculate something called work. Now, we have a colloquial definition of the word work, but in physics, the word work has a very specific meaning, and this word arises in the case that you have some force which is acting on an object, and perhaps that object is undergoing some movement as a result of the force. For example, maybe you're coming in and you're trying to move some furniture in your house, and so you push against the table, you push against the chair, and as a result of you pushing on the chair, the object, the chair, moves in a certain direction. That is when work is being done. And so in physics, the work done by a force of constant strength, constant magnitude, if that force succeeds in moving the object through a distance lowercase d, the work done is the product of the force and the distance traveled. Now, it's a little bit unreasonable to expect the force to have exactly constant magnitude. It's a little bit more reasonable to expect the force to grow maybe slightly stronger or slightly weaker as it acts upon this object. And in that case, our force would be given by a function of the position of the object. How strong is the force when the object is located here along its journey? In the case that your force is variable, how can you find the work done? You can find the work done moving the object from A to B by integrating the force function from A to B with respect to position. Let's try this formula on a simple exercise. Let's consider a force whose magnitude is given by f of x equals negative 2x plus 2, moving an object from position x equals 0 to position x equals 1. In that case, what is the total work done? Now, all I have to do is integrate from the initial position to the final position this force function. So, we find our favorite antiderivative, negative x squared plus 2x, and then we go through and we evaluate that from 0 to 1. Plugging in 0 will cause each of these terms to vanish. So I have negative 1 squared plus 2 times 1, so I have 1 unit of work done. So this is the step that is needed to find the total work done in the case of a variable force moving an object through some distance.